Hello everyone. This is Team 11 presentation for the ING 305 Mars Pro project. So basically, what we did for the Mars Pro project was we made a design idea to use a water rocket with a parachute attached, as well as a smart sensor for our project design. And we chose those specific parts in order to meet the project requirements, such as the water rocket would only be powered at the beginning of the takeoff. So it would just be powered by water pressure, and that would be just the beginning of the thrust. That would be the power that would take the rocket up and launch it up. But then for the rest of the flight, it would not be powered. So that would check off the first project requirement of the probe not being powered for at least 50% of the flight. And in terms of safely landing, we have a parachute that would be attached to the top of the rocket. As you can see in the pictures, there's a yellow ring that goes around the top of the rocket. So that is where we were able to tie the strings of the parachute evenly around. So that would be able to deploy successfully right when the rocket would start to descend. And in terms of data collection, we thought that the best thing to use would be a smart sensor, which is basically just a small, very small, and a very small sensor that barely weighs anything. I think it weighs 40 grams. And so basically the sensor collects temperature and humidity, and it'll display the data on an app on the iPhone. And it displays the data live, and even when it changes, it'll change live, and it'll show all the data live. So basically, those were all the parts that we chose and why we chose them in order to meet the project requirements. And in terms of the actual parts and subsystems, we basically we divided the whole project into 3 different subsystems and sub-teams, so each sub-team for each subsystem. So basically the subsystems consisted of takeoff, landing, and data collection along with calculation. And those subsystems were distributed to 3 different sub-teams. And all the sub-teams worked together to successfully integrate all the systems together. In terms of calculations, so we did our predicted calculations by taking the weight of all our parts together and adding them up to get a total mass. And we got our weight by just multiplying the mass of our total project or rocket system, and just multiplied that by the gravity, so 9.81. And we were able to use the weight to also get the thrust by measuring the nozzle area and multiplying that by the predicted PSI we needed, which was 30 PSI, which would take the rocket up to at least 100 feet. And we basically used the thrust and force to retrieve the predicted acceleration, so how fast the rocket would accelerate up to reach 100 feet.
First of all, for the testing, we used the preliminary test. We used 10 PSI for the takeoff, just to see how far the rocket would go. And then for the landing, we used the parachute on the 10 PSI as well. And then for the data, we used the sensor in the apartment, and then saw the temperature in the apartment as well, and compared that to the app. And then we attached all the 3 subsystems together and launched that to 30 PSI, and everything went very well. The rocket went well over 100 feet, and we estimated it to be around 140 feet.
يلا 1 2 3. الله يلا بلشت. 1 2 3.
سلام.